Hello everyone. Okay, so the next type of problem is analyze the symmetric frame and indicate the final line moments and also sketch the frame. Okay, so in this frame you can see here, this is called as one bay. Okay, this lower portion. Okay, there is another frame over it. Okay, so it is called as double story. So, okay, so if you draw only this one small thing, that is A, B, E, F, that becomes one bay, one story. Now it is complete here. So again on B and E there is C and D. So this complete frame becomes a double story, single story, double story. Okay, so there is a two story frame, and there is we can see here there are columns here. There is A, B, E, F, B, C, E, D. Okay, so these are the columns. B, E, and C, D are called as the beams. All right, and now you can see here it is a symmetric frame because BE is also loaded. Okay, BE is loaded and CD is also loaded. Where you can check here, if you cut, the meaning of symmetric is if you cut the frame exactly at the center and you flip it over, so it is going to be symmetrical, it's going to be identical. Okay, that's why it's called as symmetry. Okay, if you cut it across and see to the left side and to the right side, both will be the same. Okay, so that's how it's called as symmetric. So you can see here this is 4 meter, this is also 4 meter. I values are same, here also I values are same. 90 kilonewton is UDL acting in BE. Same 90 kilonewton per meter is acting in CD. So both are UDLs. And the CD has 2I, BE also has 2I values. Okay, and this is 8 meter. So if you cut the frame across, so it's going to be symmetrical. That's why it's called as symmetry. Okay, now there are two ways to solve the problem. Because it is symmetry, you can make this simple. So when you cut this section across, and if you see to the left side, only the left side portion you can solve. Okay, it's as good as finding the right side also. Okay, whatever forces you find here to the left side. Okay, ultimately this they connect each other. Okay, C connects D, B connects E. Okay, so whatever you solve to the left side, the same will be repeated for to the right side. So that is one way. So that is a simple way that we'll be studying later. So first let us study the difficult way. That is how to draw complete frame taking all the joints here, considering all the joints. Okay, so right now, so first as usual things would be same. That is finding fixed end moments, then finding the rotation factor, and then followed by the complete rotation contribution. Okay, this is the rotation contribution. Okay, it looks little bigger. Okay, there's too many calculations, but it's very simple because these are all the iterations. These are cyclic. You should do it one by one, then it becomes simple. And finally, you'll calculate the final end moments. Okay. All right. So the best part about this Carney's method is, um, if you have seen the previous two methods, that is slope deflection method or moment distribution method, there we had only one frame as such. Okay, only this lower portion. Okay, and there would be extra extensions here or to the right side. Okay, the best part about Carney's method is you can solve multi-story frames. So this is double story. If there is another frame over this, that also you can solve using Carney's method. So it is the simplest way to calculate the frames here. So that is the best part about the Carney's method. Whereas the previous two methods, it is slope deflection method and the moment distribution method, uh, their use is, the application is very limited. Okay, all right. So the first step is fixed end moments. So in fixed end moments, again as usual, first MFAB, MFBA, there is no forces acting in ABBC. Okay, similarly in DEEF. Okay, so because there are no forces acting here anywhere in this column, so all the moments in this columns are zero. So we have written here zero. All right. Next, the only which moments which occur is, you can see here, MFBE, MFCD. Okay. So both have same UDLs, same span also. So you can sum this up. So MF BC, so MFBE and MFCD is equal to minus WL square by 12. Okay. So it's minus 480. Similarly, MFDC and MFBE, MFEB. Okay, if you see from the left side, so it is plus. It's plus WL square by 12. So it's 480 kilonewton meter. So that's the first thing. Next step is once you calculate the fixed end moments. So fixed end moments will occur only when there is load acting on it. Okay. So next is rotation factor. Okay. So in rotation factor, so again, I'll use the formula that is rotation factor is equal to minus half summation k by summation k. All right. Now I can see here. So there are four joints which connect each other. So this is B, C, D, and E. Okay. B connects BA, BE, BC. Then C connects CB, CD. D connects DC, DE. And E connects ED, EB, EF. Okay. So all these connecting members you have to consider. All right. So now again, nowhere in the beam, nowhere in this frame, you can find out any support which is simply support. So all the supports like A, B, C, D, E, and F. Okay. Of course, these four are the intermediate supports. So intermediate supports are always treated like the fixed supports. So all the supports here are treated fixed. Okay. So the formula would be this is the formation. So formula for K is 4EI by L. Okay, because all the ends are fixed and all the intermediate supports are treated as fixed supports. Okay, first let us start with the first joint, that is B. Okay, so whenever writing this also, it is very important you write it like this only, that is BA, next is BE, then BC. So let it go in a cycle. Hmm? All right. So first BA. So it is 4EI by L. L is 4. Okay. So it's EI. Next BE. BE is this. So BE is again 4EI. Instead of I, it is 2I divided by L. That is 8. So again it is EI only. Next, similarly BC. BC again 4EI by L. Okay. Sum up this. So it is 3I by L. Similarly, come to CD. Okay, now CD is CB, again intermediate support, so 4 by L. Here also CD is also 4 by L. Similarly, DC 4 by L, DE 4 by L. Next ED. Okay, when you come to E, again it is ED 4 by L, EB 4 by L, EF 4 by L. Okay. So once you write all of this, the only thing you should be careful here is um, when you're taking the I value, that should be considered properly. Hmm? I for a different span. Okay. So next is rotation factor. Find out the rotation factor here for 1, 2. Okay. Write the formula. That is RF is equal to minus half K by summation K. It is K by summation K. Okay. Use this. Okay. Find out all these. And so once you find out, next step is very, very important. Okay. How to start this is important. Okay. Now, as usual, draw the frame how it looks like. Okay, only where you have this member joints, those are the figures where you need to box them. Smaller box, bigger box, smaller box, bigger, small, bigger, smaller, and bigger. So then highlight this. See, first as usual, draw this A and F. Then these are the columns here, right? Okay, next at V, one square box, bigger box, smaller box. Then draw this line here. Then as usual, bigger box, smaller box. Try to draw this rotation factor in a different new page, even in your main exam also. Okay, because you have to do quite a number of iterations, so do it on a new page. Okay, next, here also at D, again same, bigger box, smaller box. Okay, you have to highlight, you have to just magnify those. All right, then here, okay, this portion. Okay, bigger box and smaller box. All right, then connect this, show the column as usual. Okay, all right. So next is we have to mark the fixed end moments. Okay, so we have known this fixed end moments, that is MFCD is minus 480, DC is plus 480. So it's minus 480. Write it here, just to the right side of C. Okay, right side of C. The left side of D is plus 480. Similarly, here also, just to the right side of B, it is minus 480. To the left side of B, it is plus 480. Okay. Next is, once you draw this, see, I've already written here, always the first cycle. The first cycle is nothing but it is the number of iterations. So the first cycle, it starts with C, D, E, and B. That is like this: C, D, E, B. Again, start C, D, E, B. Okay, the cycle is like this. All right. So always start with the left top bottom. Sorry, left top corner. Okay, here. Okay, left top corner. Then come back to right top, right bottom, left bottom. So this is one cycle. So it should be more like a clockwise. Okay, always start from the topmost joint. Okay, so here is now the topmost joint. So it's like minus 40, minus 480. Okay, there is nothing here in this portion. There is nothing here. So minus 480. If you have to add, so C is the joint which connects CD also, C B also. There's nothing here. So minus 480. Okay, there is nothing here. So it's minus 480. You have to write here. Similarly here also. Plus 480, write plus 480 because nothing here. In this portion, there is no fixed end moments. Next, similarly here also. Minus 480, write it inside. Here also. Plus 480, write it inside. Okay. Next is, once you write the inside smaller squares. Okay, so next thing is you have to start with the iterations, that is the cycle, the first cycle, that is C, D, E and B. Okay, start with this. Okay, now see here, minus 480. Okay, there's nothing here. We have, this is the first step. We have not yet found out anything. This is the first step. Because it's the first step, there is no far end moment here. So 4 minus 480 plus no far end moment. So it is plus 0 into this rotation factor. So into this rotation factor is minus 480 into minus 0.25. Okay. Now, see here, this you're multiplying to the right side of C. So whatever answer you have to get, just draw this dotted line and write it here. Okay. So this your whatever rotation factor multiplier you should write to this side because it is the portion which is connected to D. This rotation factor connects D, whereas this rotation factor connects B, right? Okay, so you should start. So it is now 120, right? So minus 480 into minus 0.25 is 120. So the same here also the rotation factor is same. So you write here also just below this because the C connects B here. So this also it is 120. So both are same. Now this first part is over. Now come to joint D. Now in joint D, okay, whenever you find out the next joint, you've already previously found out joint C. So whatever moment exists in the joint, previous joint. So here the previous joint happens to be C. So that should be considered here. So in that case now 480. Okay, this is 480 plus 120. Okay, into minus 0.25, that is minus 150. So here also it is same. So this rotation contributes to this portion. Similarly, again this rotation contributes to this portion, lower portion. So again see here, you have to write to the right side of this because what happens here is whatever moments exist here will be writing to the left here. This moments will be writing above. So follow one pattern. So these are the moments, just write it here to the right side of the column. Okay, later this should not mix up, so write it here to the right side. So here also initially you're written to the right side only, so write here also to the right side. Okay, so it is 480 plus 120 into minus 0.25. Similarly here also it is same, minus 0.25. So 1 minus 50 you write here, and the other minus 150 you write it here. Okay, that's the first thing. Next, come to joint E. Okay, so when you come to joint E, so it is the same. Now E connects D also, it connects B also, but B is still the joint we need to find out. So right now E, so E is the joint which is connecting to D, right? So whatever movements occur here, that you have to consider. Now see here, this is the joint which connects each other, this 150, right? D is connected to E with this moments. So it is 480 minus 150, right? Into minus 0.167. Okay. So the answer is minus 55.11. Okay. Similarly, next, all are same here, right? So these moments, okay, one moment I've written here above, minus 55.11. Next to the left side of this, so here it is minus 55.11. That is to the left of E. Next to the right of E is again minus 55.11. Okay, so this is one iteration. We have finished. Okay, and next, see all these rotations we have found out from this step. Okay, so we have to write this properly, and wherever it connects, that you have to fill it in the box properly. Okay, now next is joint B. Okay, so in joint B, it is minus 480, right? So previously existing. Now this is very important. Okay, see joint B, it is connecting C also, it is connecting E also. So in C also you already have the moments which you have calculated here, right? See here, C is connecting to B with these moments. This is the first step, we have already calculated this. So it is 120, and B is connected to E also. So that is minus 55. See here, these connecting moments, whatever moments exist here, we'll write it here, right? So it is now minus 480 minus 55.11 plus 120, which is already obtained here. Okay, so if you add all of these, then into minus 0.167 is 69.323. Similarly, again multiply with this, so it is 69.323, and then here 69.323. So you have calculated all three. So whatever you multiplied here, write it here to the left side. Okay, right side you have already found it from the top. So the left side, write this. Then this moment, write to the right side here, and here B lower. So write to the this portion, lower portion. Okay, so now this completes one cycle. Okay, now this again cycle repeats. Okay, so right now if you try to solve, there are only these values, that is 120 minus 150 minus 150 minus 55.11 minus 55 minus 55, 69.32, 69.32, 69.32. So this is like a first cycle and first set of moments. Now let us start with the second set. Okay, now how to start the second set is, now again see it, again we'll start with same joint C. But this time, joint C, when you're starting joint C, you have already calculated the moments in the first cycle. So those are the moments you have to consider here right now. Okay. Now see here, this is very important. Second cycle. That is, C connects D also, it connects B also, isn't it? Okay. So now, so it is C, that is minus 480 in this portion. Then it connects D. So from D, you have to consider the moment, means it is minus 150, right? Similarly, again from C, if you have to consider to the lower portion of this from the column, so it is plus this portion, that is 69.323. Okay. Okay, so whatever moments when you add these exists, so add the moments, then into minus 0.25. Okay, so into minus 0.25 is 140.169. Similarly, it is the second iterations, write it here also. It connects the C connects D also and the column also. So it is 140.169. Then come to next joint D. Again, joint D, it connects DC and as well as DE. All right. So now same procedure. So first moment in joint D, that is 480. Then from previously, so previous step which you have calculated is 480 plus 140.169. Okay. Then plus again what you have calculated here from E, you have to take moment from E. So it is minus 55.11. Okay. Into minus 0.167. Okay, into 0.167. Okay, so add all of this, so you'll get minus 68 point, okay, 1 second, so it is okay, so it is 480 plus 140.169 minus 55.11 into minus 0.25 into minus 0.25, again minus 0.25, write it here, so second iteration is over. Next come to third iteration. So that is point E. Okay, this is joint E. So E connects ED also, EB also. Okay, so it is again same thing. 480 minus the previous, from the previous step what you've taken. So previous step is this, it connects from DE, that is minus 480 minus 141.264. Then from this joint, okay, from this joint is connecting like this. So it is 69.323. Okay, add all of these, okay, into minus 0.167, write it here, 68. Then same thing, 68, and here also minus 68. Okay, next come to the last joint, that is B. So again in B, so it is minus 40. Again B connects BC also, BE also. So BC, again it is minus 40, okay, minus 40, then plus 140.169. Then to the right side, okay, again to the right side if you see, so it is the second step, that is this one, okay, 69.323. Okay, add all of these, add all of these, then into minus 0.67, minus 0.67, minus 0.67, so 68.13, all three sides, 1, 2 and 3. Okay, so this is the second cycle. So we'll finish with the second cycle. Like this, you have to carry out the other two iterations. Now again, why two iterations? This iteration should be carried out until actually usually in the step of 4 you'll get the answer, but at least the difference between the previous step should be at least one as a whole number. So you can see here, um, it is 69, then it becomes 68, 68, 68, and this is again continuing 68. So here also 138, 137, here also same, 137, 130. Okay, so here also 137 and here also 137. Difference, it is same. So here 68, 68, no much change. 68, 68, no much change. Here also same thing. Okay, now this is the time where you need to stop. So in Kani's method, most of the time within 4 steps only you get the answer. So at the fourth step only you can stop this. Okay. Also, once you stop this, now you have to again highlight all the just box all the final moments. Okay, so those are the moments which you're supposed to use now. Okay, now see here, um, in this portion. Okay, so this whatever moment is here, so that is CD. This moment is CD, 137. Next, CB is again 137. Next, BC is 68. Okay, next, DE is 137. See, whatever you start writing closer to the joint, those becomes the moments. Similarly, here in E, this is you're writing closer to E. Okay, so it is ED is minus 68. Next, this portion. Okay, so again, BE 68. BA is 68, whereas AB is 0. There's nothing which starts from A, but everything starts from B here. Okay, so see here, as we go on writing here, so it is 68 is BA, AB is 0. Likewise, FE, okay, you can see here, FE, these are the moments here, minus 68. EB is minus 68, whereas FE is 0, because there are more moments occurring in the fixed support. Okay, so once you write this, and it's always better once you box these up here, just below that only go on writing the moments. Okay, so you can write here BA, BE, EB, EF. Okay, just below this only. I have not written here, of course, but it's better you start writing here. So here also same, this moment, CD, CB, and BC, BC here. Okay, just go on writing like this, then it is easy for you to use it. Okay, now you can see here again the formula goes like this. So if you want to find the moments, that is MAB is equal to FEM. Okay, FEM plus that is fixed end moments plus 2 times near end plus far end. Okay, so MAB, fixed end moments in AB is 0. Okay, so near to A, so 2 times near end. So with respect to A, so it's always like this. The first alphabet is the near end, B is the far end, right? That's how we write it. Here also MBA, near end, near to B is the first support, A is the far support. So with respect to A, okay, it is 2 times near end. So near to A is nothing, 0, right? Far to A is BA, that is 68, right? That's how we are written here. Next, come to BA. So BA also same thing. So moment in B. So fixed end moment in BA is 0 plus 2 times near end. So with respect to B, near is this only, BA. So 2 times 68, okay, plus far end. So with respect to B, A is far. So far end moment is 0. So you get this answer. Okay. Now come to BE. Okay, SEM. BE, only this portion. Okay. Now fixed end moments in BE. So fixed end moments in BE is minus 480, right? So minus it. Then then plus 2 times near end. So with respect to B, near to B is 68. So it is 2 times 68.7. So with respect to BE, B is near. Far end of BE is E. So end E, it is minus 68.68. So 2 times 68.708 minus 68.68 is this. Okay. So like this, you should go on finding out. So the only thing you should remember here is how to write these movements here. Okay, write these movements properly, and then recognize these properly and write it here only below. And with respect to the given joint, near and far end, so always the first alphabet becomes the near support, next alphabet becomes the far support. Okay, the formula remains same, that is fixed end moments plus 2 times near end plus far end. That's how we get all the moments here. All right. Okay, this is how you solve the problem. All right. See, there are many joints here, so this is how you calculate all of these. Hmm? So it will be equal and opposite. Okay, and then you need to show here. Okay, see here, you have to sketch this. Okay, so if you have to sketch here first, again things would be same, clockwise positive, anti-clockwise negative. So AB, it is 68. Hmm? So it is positive, so it is showing in, you have to show it in the positive direction. Then here also it is positive, so it is 137, show it in the positive direction. Then in BE it is negative, so minus sign is taken care by the arrow, so show it anti-clockwise, 411. All right. So in BC again it is positive, so it is 274. So like this you should go on showing. The only simple thing here is all the clockwise movements are, all the positive movements, clockwise movements are positive, all right, and anti-clockwise movements are negative. You should draw this properly, right? Okay, so once you sketch this, that's all. Okay, ultimately you need to sketch the final movements here. So once you sketch the final movements, that's all. Okay, all right, so with this we complete the problem. Okay, it is the same sway frame. If it is symmetric, it is easy. Okay, only thing you need to, the main point of importance here is drawing this. So once you understand the drawing this with the iterations carried out, okay, and the cycles, so always start this with a clockwise directions. Okay, let it be clockwise. So complete the first cycle, then the second cycle, finally highlight. So once you find out all of this, it's easy. So ending up with these moments is important. All right, so once you finish this, finally is just the writing the formula, applying the formula, and simplifying. All right, so with this we complete the problem followed by the sketch. Okay, all right, that's all for today. Thank you.